Hello everyone. I'm Dominik, and I work on everything feature flags and experimentation at Vercel. And today I'm joined by Joe from Statsig, and we're going to do the workshop about the Flags SDK, and also how to use the Flags SDK with the Statsig provider. While I'm still introducing everything, maybe you can already go to this website. This is a little companion application that we've built, and it's going to help you just follow along with the live demo and live coding. And Joe and Thomas here, they will also walk through the audience, and in case you get stuck, just raise your hand and they can come and just help you so you don't get stuck. If you go to this website, you will be greeted by this, which you can click on deploy, which will bring you to Vercel. And then in here, you can connect it to your own GitHub repository. If you can, just keep the name, click on create. And okay, obviously I practiced. We click on create. And now it's going to suggest us to create an environment variable. This is a secret that we'll use later. I recommend not changing it because it needs to have a specific length to work, and we generate this for you automatically. So you just click on deploy. And while that's deploying, we can go ahead with the rest of the setup in the quick start. And the next step would be to git clone, and remember to replace your username in here. I'll make it a bit bigger. And then you can follow the rest of these onboarding steps. And in the meantime, because we don't have so much time today, I'm going to talk a little bit about what exactly this talk is about. So I want to show you something that I see a lot on the web, which is when you load a page, the page loads and suddenly your whole layout shifts down because there's an experiment that's running on the page. And it's a really bad experience for anybody visiting the website. And especially if you want to buy something and then the shift happens so you don't hit the right button. And the reason something like this happens a lot is because of how feature flags are used in the client side. So when you have your browser and the browser requests the page from the server responds with a page. Then in the browser, the provider's SDK starts loading, and it contacts the feature flag or experiment provider to find out what the user should see. And then the provider's SDK realizes, hey, I should actually be showing this experiment. And then the experiment pumps up, and that's what leads to the layout shift or the Zeng when the page is loading. To eliminate this problem, we created the Flags SDK that works with Next.js and SvelteKit. And I'm going to show you today how it works with Next.js. And here's a small preview of kind of the experience that we will have at the end of the demo. So this is the landing page of the Flags SDK. And I can actually come in here and I can change the headline, for example. And I can also disable the banner here at the top. And you will see that if I reload the page now, I don't get any layout shift. It's just immediately correct. And you would think, hey, Dominik, that's so easy. That's just server-side rendering. I can do that. But I want to show you that when we open the network tab, let's make this a lot bigger, we're actually hitting the Vercel CDN cache, which means that this page is served statically across the globe, which is also why it's extremely fast. We don't need to go to the single rendering region of our application. We can serve it from the CDN globally. And by the end of this talk, you will be able to have an experience like this for your own static marketing pages, for example. Cool. How are we with the setup? Are people following along? Everything good? Yeah, nice. Cool. So the first thing that we want to do is in our application, we can add our first feature flag and define it in code. And the way this little helper or companion that we have for the workshop is built is you can always copy the whole code because I always repeat the whole code just to make it easy to follow along. So I'm copying this. I'm going to our project, and then here I can create a flags.ts file, and I paste the code. So what we did here is that we create a feature flag called summer sale, and we give it a default value in case this decide function would throw an error. It can fall back to the default value. And then in our decide function, we actually return true. So this feature flag would currently be on for everyone. And then the next step that we can do is we can actually use this feature flag in our page. To use the feature flag, we just import it, and then we just call it as you would call any other function. So we don't need to call a specific provider SDK, you just call the Flags SDK. And this gives us back the value of our feature flag, which we can then check to determine whether we should render our component or not. So if I go back here to the page, and I paste all this code, we see that these are the lines that we added. We come back, let's get rid of this. And if we reload the page now, we see that we have our banner now. Now, it's not really useful to have a feature flag that's just on for everyone all the time. There's not really a point in that. So let's go to the Flags Explorer. This is another tool we have. And I'm going to show you what this does, and you can also follow along. So let's change our decide function in the feature flag definition to just always return false. And now we can create this next endpoint, and our Flags Explorer, which is a tool of the toolbar, can make a request to this endpoint to find out about the feature flags that your application actually has. So if we copy this, and we create a new file in here, in our app folder, and we copy the content over, you can see now that we are importing our feature flags in here, and we are returning them from this endpoint, and the endpoint is authenticated, so only it knows kind of whether you should have access or not through the toolbar, so you don't actually leak your feature flags. You can keep them confidential. So now, if I go in here, and we reload our page, we can, in the Vercel toolbar, you can find the Flags Explorer here or here. And when you click there, you should see the feature flag that we just defined in code. And now our Flags Explorer actually knows about this feature flag. And what's really cool is that because the feature flag is currently off, we don't see it. But I can create an override where I turn the feature flag on for myself. And if I apply this override, we're now overriding the value that's defined in code. So we can test already what the page would be like if we merged it, if we released it to production, for example. And this is so useful already because you don't really need a feature flag provider. You just declare a feature flag in code, you turn it off, but it still allows you actually to have safe releases because you can merge your feature flags to merge your features to production behind feature flags, and then you can test them by overriding them for yourself. And if everything is fine, then you can, for example, make another deployment where you actually change the value in code to turn the feature flag on for everyone. The other nice thing about this approach is that you can have short-lived branches. So instead of having this big pull request open for a long time, that would just put your feature live immediately, you can have a feature flag that's always off, merge all your changes to production, you don't show them to your users yet, and then when you feel comfortable, you turn the feature flag on. And this just avoids merge conflicts in your workflow, and we do this all the time. Another nice thing about the technology behind the Flags Explorer is that you can also override your feature flags during end-to-end testing. So you can, for example, test the state where the feature flag is on and at the same time also test the state where the feature flag is off, just by configuring these overrides also programmatically for your end-to-end tests. So far, every time we wanted to use a feature flag, we had to, every time we wanted to change a feature flag, we actually had to redeploy our application because we wanted to change the value in code. So the next thing that I want to show you is edge-config, and edge-config is this data store that we built at Vercel specifically to power feature flags. And the edge-config can be edited through a UI in the Vercel dashboard, or you can also edit it programmatically. And in edge-config, you can store JSON. Like here's a flag, and the flag is currently disabled. And then in our flags.ts file, we could use the edge-config SDK to just get our flags key, and then we check the sale to see whether it should be on or off. So we are just accessing this value down here. There's something really cool about edge-config, which is that edge-config is actively globally replicated, and we collocate the data in edge-config with your deployment. So if you have something like middleware that's running in every one of your compute regions, edge config is also going to be there, co-located right next to your functions. This means that we have incredibly low latency, and right now our P95 is actually 1 millisecond, our P99 is 4 milliseconds. And these zeros here, they're because we can't measure more precisely in here, and these are basically cache hits where we already have the value and we just return a JSON object that you already have a reference to. So they are close to zero, but of course not exactly zero. And this is measured over about 200 million requests in edge config. Cool. If you're using edge config, like if you are that bold, you can literally manage your feature flags just in edge config, and then you can use an adapter that we publish as part of the Flags SDK to read your feature flags directly from edge config. But eventually you're going to outgrow this, at which point you probably want to start using a flag provider or an experimentation provider like Statsig. And then we have a bunch of adapters that we publish, and you can use the adapter to replace your decide function basically, which will then decide the feature. So this will hand off deciding the feature flag to whatever provider you're using. So another feature of the Flags SDK is so far all of our feature flags were either on or off for everyone, but you probably want to serve a feature maybe to only a certain part or segment of your users. So we have this identify function in the Flags SDK that allows you to determine who you are evaluating the feature flag for. And in this case, we're just looking at the request headers to look at the user agent. But you can do kind of whatever you want in here to figure out who your user is. You just have to be a little bit mindful if you're doing something at the edge and your database is far away. It's not a good idea to read a database because it will just introduce a lot of latency if this runs in your middleware. Cool. When the return value that we have here goes, we receive this value in our decide function as entities. So we get access to this browser that we determined, and that way, for example, we could release a feature flag only for our Chrome users. Another thing that I want to mention that we're not actually going to do in code because we don't have that much time is that you can deduplicate, and deduplicating basically means that you do the work only once per request. So if you have 5 or 10 feature flags and they all need the same identify function, you can dedupe your identify function and then pass it to the feature flag. And this means that this in here will only ever run once per request, which is very good in case you're generating random IDs in there for that specific request, or just in general to avoid duplicate work in case you do something expensive here like decrypting a JWT or JWE. The other thing about why did we ship our own dedupe function in the Flags SDK if there's already something like React's unstable cache, and this is just because if you use unstable cache in middleware, you would pull all of React into middleware, which massively increases your bundle size of the middleware. And unstable cache is actually a no-op in middleware, so you would do all of that for nothing. That's why we shipped our own dedupe. But once something similar lands in Next.js, we can get rid of this in our Flags SDK again, and we can just use the Next.js primitive. Cool. The next part is precomputing. This is what I showed in the beginning of how we can keep pages static. So the goal here is that we want to evaluate our feature flags in every single region by leveraging middleware. And then our feature flag can decide which experience a user should see, and we can serve that experience from our CDN. There's a manual way to do this, which would be to just create page A and page B. So you create home A and home B. And then when a request arrives in the middleware, you could figure out should this user see version A or version B, and then show the right version to the user. And here's the source code of what this would look like if you would actually do this yourself. But the problem with this is, so we would only run this for the root path. We then check our feature flag, and then depending on whether the feature flag is on or off, we either rewrite to home B or home A. And down here is where we rewrite, so the user would never actually see home A or home B in their path. They would always just see the root. But the problem with this approach is that it doesn't scale. If you have more than one feature flag per page, you need home AA, home AB, home BA, and home BB, just to handle all of these variants. And it's very hard to deal with this combinatory explosion. And the other aspect that's very hard is if you have a single feature flag that's used on multiple pages, because then you need to create these different variants for every one of your pages. That's why we created this concept of precomputing in the Flags SDK, and this helps you to eliminate this problem. So when you're precomputing, and if you're still following along, we only need to copy this section down here. So in our flags.ts file, we just export our product flags, and this is an array of the feature flags that we want to pre-compute. And if you have multiple pages, you could actually have multiple arrays that you're exporting, but this is a little bit advanced. So for now, we just make a single array that contains all of our pre-computed flags. And the next step would be in our middleware. We're going to call the pre-compute function with the feature flags that we put in this product flags array. And this will give us back a code. And we can then rewrite the request to that specific code. So it's very similar to the manual approach. It's just that we introduced this dynamic route segment that's going to handle, to be kind of the transport for which feature flags the user should see. So if we copy this and we go to our middle, we have to create a middleware. We can paste it in here. And now if we go back, there's one last step that we need to do. Two more steps. First of all, because we introduced this dynamic segment, we need to rename this folder, the main folder that I prepared for you. So you can literally just come in here and rename it to code. And this is the dynamic route segment that we're going to use, that we are rewriting the code to that we determine in the middleware. And this allows us now in our page to actually access in here from our params this specific code that was generated. So I'm going to copy this over into our page file. And here you can, here we are now accessing this code that's part of the dynamic route segment. And then we call our feature flag and we pass the code that was pre-computed by the middleware along with the array of feature flags that we pre-computed. And what this gives us is basically an instant evaluation. So when you call this feature flag, you don't actually evaluate the feature flag, you just read the value that was determined by the middleware. And if we come back to our page now, we actually still see the feature. So it seems everything to be working. But our page would still be server rendered because we didn't actually do anything to make the page static. So that one more step that we can do is we can turn on ISR by just exporting generate static params and returning an empty array. So if I come in here and I return this empty array from generate static params, we've now turned on incremental static regeneration, which means the first time a specific combination of feature flags is requested, it's going to get rendered, and then it stays in the ISR cache and gets distributed globally. And then every request after that hits the same, that ends up needing the same feature flag state, will just be servable from the ISR cache. So we achieved this goal of having a static page that can have experiments on it and that's immediately rendered correctly. And just to show that, if I reload here again, okay, it's still the same banner. There's one more optimization that you can do, but you have to be a little bit careful with this, is we have this function called generate permutations. So instead of waiting until the first request needs a specific combination of feature flags, you can actually, at build time, list out all the combinations or permutations of the states of feature flags that you can have, and we can pre-render them all at build time. This is very powerful, and you have to be a little bit careful with it because, again, there could be combinatory explosion. If you have a lot of feature flags, you can blow up your build time and it will never finish. So there's a second argument in here that gives you the permutation, and then you can actually check on the permutation and return true or false depending on whether you want to keep that specific combination of feature flags or not. Let me remove this again. So now if we go back, and I'm running this in production, so I can't really show you the ISR cache, but if I reload this and we go to the network tab, we can see that we are now hitting the Next.js cache, which is kind of the local equivalent of the ISR cache that you would be hitting in production. So with this, we achieved our goal of keeping the page completely static and using middleware to determine what the user should see, and we eliminated layout shift. There's one more thing that we currently have in a canary release of the Flags SDK, which is called Embedding. And this is very useful if you actually want to start experimenting. So typically, if you want to run an experiment, then you need to track exposures and track events in the browser. But the browser needs to know which feature flag the user was actually exposed to. And if you use our pre-compute pattern, you might never even actually send the list of feature flags to the client. And you also don't send the context, like who were the feature flags evaluated for, to the client. Because you cannot make this information part of the ISR page. Otherwise, you couldn't, basically every user would have its own cache, so you would get no cache hits. So we need to keep all user-specific information out of the ISR cache. And with this pattern that we have, you can, with pre-computing, you just get the state of your feature flags, which determines your variance. And then on the way back to the user, I'll actually show you my napkin that explains this. So the browser makes a request to the middleware. The middleware decides which variant the user should see. We hit the ISR cache. The ISR cache contains no information about the user because it only contains the state of the feature flags, basically. And then we get from the ISR cache, we get a response to our middleware. And in our middleware, we can now embed additional information for the browser. So we can embed a bootstrap file for the Statsig SDK that's going to be used there, as well as the context, like which user did we actually evaluate these feature flags for. And this gives us the benefit that once the browser initializes, it actually knows exactly who the feature flags were evaluated for and the configuration of feature flags that were used when the decision was made. So with that, a tool like Statsig would have all the information immediately, and you can start tracking events immediately without first needing to fetch from the Statsig API the latest configuration or find out the user. And this also avoids drift in case there's ever change in between when middleware made the decision and when the browser actually receives the response from the API. That's kind of my part, and now I'd like to hand it over to Joe to show you a little bit how to use all of this together with Statsig.
Thanks. Testing. All right, awesome. Thanks so much, Dominik. Really cool to see all the features added to Flags SDK. So hello, everyone. I'm Joe, and I'm an engineer at Statsig. We're an all-in-one platform for feature development, and we provide services like feature flags, experimentation, and analytics to users at all different stages. So we work with startups all the way up to large enterprises like OpenAI, Notion, and Figma. If you are just getting started with us, we have a really generous free tier. And for startups, we have a startup program where you can apply for $50,000 in free credits. If you do want to learn more, you can scan this QR code, or you can find the team at our booth that's literally located right outside the workshop here. Cool. So I'll be picking up where Dominik left off with the demo. If you are following along, I'll be showing us how to implement a feature flagging provider using the Flags SDK. And we'll leverage the Statsig Marketplace app along with the Statsig adapter to do so. And after that, I'll be walking us through how to instrument our application using the embedding pattern that Dominik just introduced so that we can get things like analytics and experimentation firing for our application. Great. So with that, I'll head back into our companion. If you do want to follow along from this point, I think there is I think if you fetch from a branch of the workshop starter called after DOM, that should get you caught up. Otherwise, I think most of my sections should be able to work regardless. So we can get started with heading over to the Vercel Marketplace to get a copy of Statsig connected to your project. So if we head over to our Vercel console, we can head over to our project, and we can find the Flags tab. Here we can install a flags provider, in this case Statsig. And important to note that we should enable edge config syncing. And this will allow Statsig to push flag configurations into edge config so that we can do flag evaluations at the edge really performantly. Cool. If we continue with the install process, we'll be put into the Statsig app page. You'll note that API keys will be synced into your Vercel project's environment variables automatically. And also, user management will happen through Vercel, so you don't have to worry about inviting users to a Statsig project. Awesome. With that, we can open up Statsig from the app page, and we can create our first feature gate. So we'll be creating a summer sale banner gate to control the summer sale banner that we saw in our shirt shop example. Cool. So if we head over to the feature gates tab of Statsig, we can get started and create a summer sale flag. Important to note that for this demo, we will be experimenting on the user ID. So we will need to set user ID as our flag identifier ID. With Statsig, you'll be able to configure a lot of different rules to target users on different criteria. For this demo, I'll just set a simple rollout rule where we'll roll out to 50% of our users. If you are setting up, if you do want to set up on more complex rules, we have a bunch of built-in rules, and you can also pass in custom properties such as like the user's country and other properties to target on. Awesome. I'll just save this flag definition. And great to note, if we head back into Vercel and we head over to the Flags tab, cool. We'll see that the summer sale flag was synced automatically into Vercel's console. So the Flags tab will be a great entry point for you to configure and update your flags as needed. We can also head over to our edge config that was created with the application, and you'll see that the summer sale flag was synced into edge config automatically. Cool. With that, we have our Statsig project set up, and we already have our first gate set up. And we can head over to our project code now, and we can start implementing Statsig using the Flags SDK adapter. Is everyone following? Is everyone up to date? Good. Cool. Cool. So in order to implement to use the Statsig Flags SDK adapter, we'll need to first pull down the package. So that's at pnpmi flags-sdk/statsig. And then one more step we'll need to do is to run Vercel env pull, and that'll grab the API keys that were set up along with the Vercel app, the Statsig app. I've already done so I'll skip this step. And the process to update flag definitions will be pretty simple. We'll just need to update the two primitives to define a flag in the Flags SDK, and that'll be the identify function, and then also how we actually decide which flag evaluation to return. We'll update our identify function to be pretty similar to our existing identify function. The only difference here is that we'll provide a identifier for our user ID. So in our flag definition, we were rolling out to 50% of all user IDs. So we need to have a identifier that will define as our user ID. In this case, we are going to generate a random ID in our middleware later, and then we'll use that as a user ID. Cool. And then the other step here is that we'll need to update our decide function. As Dominik already mentioned, the adapter has a helper function for every single type of Statsig entity. So in this case, we just need to use the Statsig adapter.featureGate call, and it'll actually grab the featureGate defined at the key of the flag. So in this case, the summer sale flag, and we'll be able to get the gate value back and then evaluate. We'll decide what group the user got put into. I'll copy this new flag definition into our project here. And cool. Just with that update, we will already have our flags being powered by Statsig in this example. And one really nice thing to note is that as we updated the flag definitions, we didn't need to update any of the call sites. So we didn't have to update any of the components. So this, because of this, the Flags SDK becomes a really easy way to update your flag definitions and change and update to new providers. Cool. One more step that I'll walk through is setting up Statsig and feature flagging providers with Flags Explorer. So if you add a couple more environment variables to your project, in this case, the Statsig console API key, we'll integrate directly into Vercel's Flag Explorer as well. I already have this set up, and I won't walk through the exact steps, but it'll be simply just grabbing an API key from the Statsig console. And what it'll look like is that inside of the Flags Explorer, there'll be a deep link into Statsig. So if you do need to update a gate while you're developing your project, we'll deep link into that gate definition, making it for another great entry point to update your gates quickly. Cool. So one of Statsig's most powerful features is that we convert every single feature flag rollout into an experiment. This is so that for every single change to your product, you're able to make data-driven decisions using your metric data. So in order to do this, we'll need to implement client-side logging. As Dominik mentioned, this example is using the precompute pattern to serve static sites. So we'll be leveraging the embedding pattern inside the Flags Canary package in order to inject both evaluation context, so the Statsig user, and the flag definitions back to the client. Note that these APIs are experimental right now, but it'll still be great to walk through the steps and kind of the pattern of how this might look. So in order to perform the embedding pattern, we'll first head over to our middleware file. And here, we'll grab the request, and we'll actually fetch it, so grab the expected response, along with the Statsig evaluation context, aka the Statsig user, and then also the flag evaluations themselves. The Flags SDK Canary has a function called embed bootstrap data, which we can leverage to take our evaluation context and flags and embed them into the response. After that, we simply need to return the modified response to the client. Also note here is this is where we're going to set the ID of the user that we needed to rely on for a previous step. I'll just update our middleware here. We'll now need to set up a component in our app that'll actually take in the embedded data. So we'll again rely on an experimental component called Flags Bootstrap Data. And if we add that to our layout.ts file, that'll serve as the component that we'll actually put embedded data into. Finally, the last part of this pattern is to actually grab the embedded data and use it to bootstrap the Statsig client SDKs. So we'll first fetch the Statsig client SDKs from our package manager. And then the important step to note is that we're going to be leveraging the use bootstrap data function. We'll hook, and we'll use that to grab the embedded data from our component that we created, and use that to grab both the evaluation context and the flag information and pass it into our Statsig provider so that it can initialize using the response from the middleware. I'll go ahead and copy these files over to my project. Cool. And with that, we will already have our embedded data to use to initialize our Statsig client. And we'll simply need to now actually use the Statsig client to log events and exposures. So we can go back to our layout.ts file, and we can wrap our project inside of the Statsig provider that we just created. And we can start logging both exposure and event logs. So if we head over to our summer sale banner, one important thing to note is that we're going to update the definition of how we render the summer sale banner, and we'll always render it now. Reason being, for experimentation, we need to be able to log events both when the summer sale banner is hidden and shown to users. So we'll update the logic here to always render the component. We'll then add a use effect log to actually call the Statsig client libraries to log the exposure. Cool. I need to also grab the packages. Cool. And now with that, we have both exposure and event logging firing. So we can head over to our project. And if I use this tool at the bottom to reset the stable ID, we'll start to see flag evaluations happen. So some users won't get access to our new summer sale banner, while some will be gated in. And we can click around, and because I imported the auto capture package from Statsig, we will also get event logs. Just to note, the auto capture package is imported in our Statsig provider, that file that we created, and it will just grab event logs like user clicks, page views, etc. If we head over to our Statsig project now, we will be able to see in diagnostics event logs start to come in. We can see exposures. So for example, for this user ID here, they passed the gate and they were served the summer sale banner. And we'll also be able to come into events, and we'll be able to start seeing some auto-captured events, such as, in this case, page view end, and also the different clicks. One thing I do want to show is within Statsig, we will run an experiment for every single one of your feature gate rollouts. So in this case, we have a 50-50 split for this particular gate. And we set up some monitoring metrics. So in this case, just like DAU. And if we head over to metric impact, because we haven't collected data for long enough, these metrics are unavailable. But for a matured experiment, you'll be able to see something along the lines of a dashboard where you can see how metrics moved for the different rollouts of your experiment. So for this particular flag, we can see that the checkout and other conversion rates improved, which you'll get for your gate that you implemented in around 15 to 20 minutes after the demo. Cool. So that's all I had. Thanks, everyone, for coming.